welcome to everybody. We are really proud to welcome two professional women here today, both highly experienced in wind engineering, who will provide us with a sneak peek into their powerful platforms. For those who are new to one or both of the platforms, Youwind is a cloud-based SaaS which helps developers and consultancies accelerate early onshore in onshore and offshore wind development by unifying engineering, GIS, and financial modeling into one workflow. And then on the other side, we have Delfos Energy, which is an AI-powered wind performance asset management software that helps renewable asset owners predict failures and maximize energy capture. These solutions are not only intuitive to use, but also capable of addressing some of the industry's most complex challenges. But we will first start off with Ana Rivera. Ana is the CEO and one of the co-founders of Youwind. She holds a degree in mechanical engineering and wind power masters from the Technical University of Denmark. And after several years of working at Siemens Wind Power and collaborating with several developers from there, she felt it was time for change to impact the industry further. So in 2017, together with co-founder Edvald Edvardsson, she decided to launch Youwind. Like I said, it's a SaaS platform to accelerate the development of wind projects. And their mission has been clear from the start, to empower users to make the right decisions based on valid data through an efficient and innovative digital tool. So today, Ana will give us a demonstration of how the Youwind platform works. She will focus on an existing wind farm in Brazil, illustrating the importance of accurate tools in the design phase. She will walk us through some of the reasoning behind the chosen site and layout, compare two different wake models to illustrate an example of sensitivity analysis and explain why you have to deep dive into efficiency breakdown from early phases, which is critical for the next stages of the farm lifetime. And next, we will have Nathianne from Delfos, who will explain her part. Nathianne is the head of performance engineering at Delfos Energy, where she leads renewable energy performance optimization across wind, solar, hydro, and BESS portfolios. At Delfos Energy, she spearheads the development of AI-powered software that enables operators to predict failures before they occur, maximize energy capture, and extend maintenance. Extend asset life cycles. Her solutions transform wind farm operations from reactive maintenance to predictive excellence, delivering measurable improvements in efficiency, reliability, and ROE across projects of any scale or geography. Nathianne, she will address one of the most pressing challenges in the industry, why so many projects fall short on their P50 goals and what can be done about it. She will walk us through the key operational hurdles that asset managers face and show how Delfos Energy will turn data into actionable strategies that protect revenue and unlock performance. So with no further ado, Ana will start off with this webinar. Afterwards, we also will have time to do a small feedback from your side and a Q&A section. So Ana, the stage is all yours.
Perfect. So thank you so much for this warm introduction, this human introduction. That's the most important part of it. Okay, so good morning, good afternoon, day, and good evening. So happy to see people from all over the world. So as I said, today we're gonna show how some of the drivers in order to get that baseline on P50 in order to actually have the goal well set when we go into operations, in which Nathianne will show you the magic behind on how to make sure that we fill that gap. So for the ones that today is the first contact on Youwind, a warm welcome to our company. Just a few introduction before we actually jump to the platform itself and deep dive on a real case. So welcome to Youwind. We provide grounded digital solutions, grounded, solid, and that for your wind farm development, both onshore and offshore. So, and we do that through our digital platform, our web-based platform. So we were founded in 2018. We've been 7 years in the market, and that's been quite a while. As I said, designed both for offshore and onshore, and that, as Sandra mentioned, the philosophy from day one at Youwind is always to empower the users to make the right data-driven decisions. So 4 pillars that define us. The first one, the people behind the tool, which is experts, wind engineer experts, that we have suffered the problems when developing wind farms, and that Youwind actually was created to fix them. So the empathy behind also in the support makes us quite unique. Then the second part is how integrated our platform is. We are a one-stop shop, and by integrated we mean that we cover in one same platform advanced engineering modeling, specific for onshore, offshore, and common, with mapping capabilities, and last but not least, keeping your business case always under control through financial and cost modeling with the right data security, because this is as important as the modeling being accurate, that the data is safe with the clients. So, but this sounds very complex. This can sound very complex. And this is therefore our third value. It has to be easy to use. If we want to make it more accessible, it has to be easy. Therefore, usability is a key factor, and seamless collaboration between members, between users when developing a wind farm is a lot of time saved, therefore money for the clients. So this is important. And last but not least, at the end, we're powered by results. The numbers are what really matters. So that all the validation done behind through our clients and many research institutes that validate all our models in order to go to bankable levels with a lot of success cases on existing wind farms. So with no more detail, let's talk about wind. Let's go to the deep dive on a real wind farm placed in Brazil. And I want to explain a bit the processing on making that funnel on uncertainty in order to reach the most accurate and reliable P50. And this is the baseline to enter in operations as a goal. So to start with, I want to welcome to one of the entry points of our platform, which is all the overview on projects, so that one company account can have endless projects, and every project would have all the scenarios, which are different sensitivity analysis performed with full traceability on who is doing what, status of each scenario, etc. So if we go to today's case, so I've developed a few scenarios for today's webinar, and this is the how the platform looks like, and I'm introducing you to this real wind farm placed in Brazil, just to put you a bit of context that we are here on the northeast of Brazil, and that just to put some context, the way the platform works is with a map in the center. Then we have on the left all the inputs to your scenario as if it would be a Lego plate, and that we would start plugging in all the inputs, components, assumptions, etc. Here we have the main outputs, let's say the first layer, then we'll go to many more layers on outputs. Then on the right side, we'll have all the mapping capabilities in which Youwind offers, to start with in GIS terms, a bunch of preset layers to get started on the screening that we'll do right now. And last but not least, here below, we have all the different layers of outputs for the specific scenario. So having said that, the first thing is what brought this developer to build the wind farm in this location, and why the layout of it. So let's enter into this funnel. So to start with, I just placed all the grid connections available. This is actually one of the presets available in Youwind for the users, and also some 10 kilometers buffer, just to give a bit of sense of distancings. So the first thing that we see in the case of the location of this wind farm is that the connection point was not too close by. So actually this is around 50 kilometers from the wind farm to the connection point. What does this mean? When calculating the P50, electrical losses must not be neglected. And Youwind offers the full modeling on the electrical system to get all those losses under control. So that's the first part. Then, meaning, when we start developing is where can I connect? Here we have. Second, let's see where is the best place to place my wind farm. I'm not going to enter into local content, permits, etc. Today's scope is purely technical. So one of the main inputs is actually how is the wind blowing in its location. So that, and for this, a good starting point is the maps from Vortex, in which we hold a very strong collaboration with the leader in wind, in synthetic wind resource, and that this is a beautiful starting point to see that actually this is a good area that is more windy than other areas in Brazil. But if we zoom in, we will realize that it's actually on this region, not the best location. And that's the first thing that pops as a questioning. So of course, when checking, this is full of wind turbines. So all the good area was already taken. So that, having said that, this area looks like a second level in terms of quality of wind resource. I'm focused on the visuals, but in Youwind, you can capture the Weibull distribution at turbine position from the very start with the collaboration with Vortex. So this is the first thing to check. Also, what is the topography? So is this a very hilly area? Yes or no? So that what we will see now, but let me just disconnect this one, not to put too many colors. So when checking the topography of it, we will see that indeed this is a wind farm that is placed on top of a hill, but not too steep. So that also explains the reason of having a quite decent wind resource. So this is, let's say, first basic parameters, technical parameters. So then the second, then the other thing to check is where we in terms of wind direction. So beautiful wind rows we have in this location, unidirectional, and that explains a lot why the layout is on this perpendicular line from which is north-south, in order to diminish wake losses to its maximum. And actually, the spacing between turbines is great, meaning that from here to here, actually we can measure it. We actually have, this is a 2.1 megawatt turbine from Gamesa, 114 meters diameter. And we're seeing 1.6 kilometers between one row and the other. So this is actually a very good spacing for lowering wakes. So, but in Youwind, you can, this is, let's say, an existing wind farm, but in Youwind, you can upload as complex site as the reality allows, with all the exclusion zones included. So you can have the most complex Gruyere cheese that Youwind can actually generate you and optimize you a layout in a matter of seconds. And just to mention that we do have several options on optimizers depending on the goal at each phase of the design. Row spacing, actually capacity, this is very much used in onshore. I do have this terrain available. How many turbines can I place? This is answered in Youwind in a matter of seconds. Or if you want to straight minimize the wake losses. So, and you can make a lot of sensitivity analysis on that. So having said that, let's go on calculate a P50 that is the most accurate as a starting point for Delfos with its an existing wind farm. So to start with, the first input, as mentioned, it is all what level of wind resource accuracy do you have? And here, yes, just to mention that all the visual impact is also a part of the platform, as we have all the 3D visualization, and you can do screenshots from any viewpoint. So just to mention that if you don't have data, Youwind with the collaboration with Vortex provides you first layer of statistic data, but Youwind goes down to wind resource grids from any source. You can upload that wind resource from any source, and all the time series studies that it's implemented in Youwind, including what is very important, which is all the horizontal extrapolation to get the best wind resource in front of each turbine. So this is one important input. And then the other, which we always recommend, is to make a sensitivity analysis on which is the wake model that you want to use for calculating the AEP. And while we don't have measurements, it is always best to use several sources. In onshore, we'll always recommend to check Jensen and eddy viscosities included. TurboPark is widely spread more in offshore, but it's also available. So, and with this, we would get the calculation on the wake losses. You can see super low, 1.9% loss. And what is the AEP? But this is only one level of output. Yeah, but then it's, okay, what if I change the model? I want to see the difference on my scenario if I do one change to my park. And this is done through, I would duplicate my scenario and just change what is the model that you want to run. And then just upload, calculate wakes, boom, you have it. So, and with this, we would have a different result, which the idea is that is as accurate as close as possible. So that means that we are converging regardless of the wake model. So, and this would be the case for if I would change the wake model to eddy viscosity. You can see that there is an increase on the wake loss just because of changing the model. Another thing is also to go and deep dive on the time series span. And this is also offered by seeing on the wind temporary analysis part of the platform to see if there is any specific seasonability and what is happening at every timestamp to my power output. So this is also a part of the studies that can be done. So, but if I want to see, am I converging to this P50? It is very important to go and compare endless scenarios. And that is carried out in Youwind thanks to this part, which is where the case comparison happens. And this is also where finance costs meets engineering design. So in this window, we can see I just placed these two scenarios, which the only thing I changed, wake model. So eddy viscosity versus Jensen. And here in the platform, we have, let's say, a picture of what it would be a business case of these scenarios. And if I deep dive on production, I'm right now in the AEP part, this is the P50 that we should be checking. And definitely there is an difference only by changing the model, but not too big. So that you have to think there's a lot of uncertainties inputs. So wind resource being one important one, and then also all the uncertainty and every single breakdown on the efficiencies. And this is another part that is very important to have it very well modeled to be the baseline on what is the goal you want to achieve when operating that wind farm. And that here in Youwind, we offer a full breakdown, being wake effect, of course, one of the kings of efficiencies, but also many other parameters like the electrics. Remember, we said the wind farm was 50 kilometers from the connection point. This, with all the modeling included in the platform, you can actually get a grasp on this electric loss. And last but not least, the world of curtailments. There are curtailments that are driven by, for instance, producing more than what the connection point can handle. This is modeled automatically in Youwind. But sometimes there are external curtailments to the wind farm. And in Brazil, right now, there could be curtailments in the grid connection that can go up to 5%. So it is very important for a developer to actually make a sensitivity study and having as an input, what if my case has a 1% forced curtailment, 2, 3, 4, and you can compare endless scenarios inside the platform. So, and just to finalize, even though I've been focused more on the technical part, in this part of the platform is where we have all the outputs in terms of CapEx, DevEx. with a full breakdown to understand where are we, the cost is adding up, OPEX, and last but not least, all the financial indicators. So to know which level are you in at LCOE level. So having said that, and a full cash flow of the scenario, the main scenario. So having said that, this is just the starting point. This is in pre-construction phases, and that the more accurate we have the baseline, the better is to know what is the goal that you're really aiming as a developer when you are operating an onshore wind farm. So that we are on the design part, and now we're jumping throughout the lifetime to the other side of construction, to the operations. So Nathianne, all yours.
So thank you, Anna. So I believe now you can see my screen. So hello again, my name is Nathianne from Delfos, and I'm a wind farm specialist. So at Delfos, we have developed a software dedicated to monitoring operational wind farms and helping managers to achieve the production goals. One question that we have been asked countless times is, why isn't this wind farm reaching its P50? So sadly, our industry has a history of overestimating P50, but in the past, it was often linked to overestimation of the wind resource. But today, with the advanced tools available for wind farm design, such as Youwind, that issue is behind us. But we still find some wind farms that struggle to reach the P50. So the challenge now lies in the losses and uncertainty related to availability, environmental conditions, and external curtailments. If these losses are underestimated or not properly managed, they can lead to serious problems. But what are the risks of not doing anything? So first, if you don't monitor these losses, you have no idea what to improve, and your operational ends up being a purely reactive, basically firefighting all day long. And if there is any underperformance in the power curves going unnoticed, you may miss the right moment to request a review from your manufacturer. The results, financial problems that can put the viability of your wind farm at risk. So by now, I hope I have convinced you that monitoring every loss is essential. So the next question is how to do that. A wind farm generates a huge amount of real-time data. You have data coming from the SCADA systems, metering systems, and maybe additional sensors. And that's a huge amount of data. So, and there's plenty of analytical tools over there. So if you don't choose wisely, you may end up buried in time-consuming process and endless spreadsheets. So how do we actually turn all of this data into achieving P50 goals? So my advice would be set the right strategy and choose the right tool to match your wind farm's reality. And you can break down this advice into 3 steps. So the first one, understand the performance gaps. So identify where the losses are higher than expected. Then select the best tool according to your problem. And this might mean using some AI or machine learning powered tools in order to achieve, to tackle this issue, and then build a proactive maintenance plan. So now let me illustrate these 3 steps using Delfos platform. So welcome to the Delfos platform. We have several apps here, but for this webinar, we are going to mainly use the energy losses app. So this app connects the wind farm design with the operational wind farm data. So in the left side, you have your goal production. Let's say it could be the P50. And in the right side, you have the energy that was delivered at the connection point. And in between, you have several losses categories. And think of it as a snapshot of your wind farm, and you can quickly see where are the biggest losses and if they are exceeding the expectations or not. And this visualization is very intuitive. If a loss category is above the expected value, the bar turns red, and if it's within the range designed by project, it stays green. In this example, I would be concerned about the curtailment and the performance. So the natural next step will be to use a performance tracking tool. On Delfos platform, it will mean to use the APM, Asset Performance Management, which is a tool that combine 5 analyses together. The first 2 analyses are a comparison against the contractual power curve, and you can easily identify which wind turbines are underperforming, like this first one. So we have the color red. It means that the wind turbine is not doing right in comparison to the contractual power curve. And then you have 3 other analyses that can narrow down your problem. So you can analyze the performance of the generator, the pitch system, and the yaw system. So and you can spot cases like that where you see that the wind turbine is underperforming, and you can narrow down the problem to the pitch system. Just to illustrate that, I'm going to open this pitch analysis. And here we have another beautiful application of machine learning models. So what we have here, using that data-driven approach, we learn the behavior between the pitch angle and the normalized wind speed, and we learn the central trend and also the operation boundaries. And the measured data are the blue dots. So as you can see here, we have 2 patterns that's not desirable at all. And this tool was able to identify a problem in the actuation of the mechanical systems for that wind turbine. But I know that it isn't the case, but let's just imagine that this wind farm is facing an issue regarding availability, sorry. So we would have larger red bars here, like in other downtimes, and in this bar, this column, other downtimes. So the next step would be using a tool that can predict that failure before any downtime happens. And using the Delfos platform will be our failure prediction tool. And just to illustrate that a little bit further, this is one case of failure prediction using our failure prediction tool. Please focus on the graph below. You have the red time series, which is the measured temperature of the shaft bearing. And you have the green time series, which is the expected value calculated using machine learning models and all of the operation conditions that are relevant for this case, such as ambient temperature and active power. And the difference between these 2 time series is the black time series above. So when this difference is higher than the uncertainty of our machine learning models, we are going to raise an alarm and warn you that there's a problem going on with your wind turbine before any downtime occurs. So for example, for shaft bearings, we can predict its failure even 11 months in advance. So this was real high-level demonstration of how you can combine Delfos tools in order to achieve your P50 goals in 2 scenarios. So the first one, you have a problem regarding performance, and the second one, you have a problem regarding availability. And so to wrap up this section, I would like to give you 3 takeaways. So in order to achieve P50, 3 things are required. So the first one is a solid wind farm design. The second one is accurate loss estimation. And the third one is an efficiency operation plan focused on monitoring and managing these losses. So thank you very much for your attention. And Sandra, the stage is yours.
Thank you very much, both Anna and Nathianne. I think you had really interesting presentations, and I'm sure people have learned more about Youwind and Delfos and all the added value that these digital tools can add to your company. So I would also encourage everybody, if something was not clear or if you have any questions left, please, we have a Q&A section here in the Zoom meeting. Leave all your questions there, and we will have, in 3 minutes or so, we will start off with the Q&A section. Meanwhile, I would like to have a little bit often feedback from the audience. For us, it's really important to know what your thoughts are, what you think about the webinar, maybe ideas for next webinar. All that information is so useful for us in order to be able to make our webinars even better for all the people who come and register for those. So I would just like to ask you nothing, 2-3 minutes of your time. I will start the feedback poll right now. I think everybody can see it. There are 3 questions on that, and I only need to know, for anyone who feels like filling it out, please do so, and you will be of great help, not only for us, but also for you in the future to make the webinars even more tailored to your needs. So while we have these 3 minutes,
and if I can add in comments,
yes.
I hope that we have given you some insight content, and as with experts that Nathianne and myself are, any suggestion on topic that you think it might be interesting, we're gonna take into account in our funnel for all the webinars that we have planned ahead. So
exactly. I mean, in the end, we do the webinars, of course, to inform you, but also if there's any information or something that can be added to those webinars, or any topic that you're missing out on, or that we can explain to you, please feel free to put that in the feedback form, and we will have a really close look at it, and start designing our webinars also based on the input we get from you. So yeah, I would really like to thank everybody who fills it in. I'm seeing that there are quite some people already really busy there. So that's great. I will give 2 more minutes, and then we will go on. For the people who already filled in the feedback form, if you have any questions, either for Anna or for Nathianne, please feel free to put them in the Q&A section, so we can tackle those now. The questions we cannot answer because lack of time, don't worry, we will answer them anyway. If you put in your name and your company afterwards, I will send you an email to each one of the questions we haven't been able to answer here, and I will send you a personal email with answer to that question. So no worries.
Remember, there are no stupid questions. There are only stupid answers. So the pressure is on us.
Exactly. Exactly. Okay. So 1 more minute, if you still feel like it. They're anonymous, the feedback form, so don't worry. We won't see your name on it. So I see that we have already quite some questions. So I'm going to close down the feedback form, and we're going over to the questions. So we still have some time for that. Okay. So we will start off with a question for Anna. Anna, how can I use my own data in Youwind and how safe is it?
Yeah, so actually Youwind offers full flexibility. So it is true that we do have libraries in order to get you familiar with it. I will just answer with the screen. Here we have, yeah, so we do have for all the components of our libraries the possibility to import your own data. So that goes from wind resource typology, statistics, time series, GIS layers, market prices, and any single, let's say, the flexibility to add components to your library. And safety is actually a backbone value of Youwind, because if we would actually be seeing anything of what our clients are uploading, we would be dead tomorrow. Sorry for the very direct answer, but cybersecurity and data protection is a backbone of Youwind in order to make sure that all the data uploaded by the client is only seen by the client. And we have full IT protocols on the way that we support to our clients through making dummy cases when we have live support Teams meetings, etc. So this is an important matter. And also any single parameter, if I would go to turbines, for instance, every single parameter can be tuned. So if it can be, you can choose what is modeled by Youwind and what you want it to be an input as a user, and you have full traceability on that.
Thank you, Anna. I will go on with another question for you before heading over to Nathianne. Can you introduce the noise impact in your designs?
Actually, you can. It is fully available to our clients. I'm just wondering if I can share my screen just to show you that it's real. If I would just, yes, this is a scenario that I have from another case, and just to show you that this is all the noise modeling, which you can choose different noise curve per power curve in one turbine profile, and that you can have in visuals and in numbers terms all the outputs on how is the noise level, fulfilling regulations, and also from any receiver that you want to place in the map. So yes, it is full available to integrate noise in the design phase with Youwind.
Perfect. So Nathianne, question for you. Are you working only with SCADA data?
Not only with SCADA data, we are able to integrate SCADA data, metering systems data, met masses if you have them available, and also extra sensors that you have in your wind farm. So we are able to work like a hub for all of this information and help you to combine them in order to generate insights that are helpful for your operation.
Perfect. Thank you very much. Another question that I have for you, Nathianne. Can we have predictive analysis for wind turbines?
Yes, we have a tool called failure prediction tool, where we use historical data to learn the individual behavior of each one of the wind turbines. And every day we compare the yesterday behavior with the historical behavior. And if we spot a difference, we provide you a predictive alarm that say, oh, one anomaly was found in your fleet. Please check that before any downtime happen. That's pretty much what happened using our failure prediction tool.
Perfect. Thank you very much, Nathianne. I think we have time for just a couple more questions. I will do one for Anna, one for Nathianne. Anna, what efficiencies can you take into account in Youwind? Can I input my own values?
Yes, and actually, as shown, we have a full breakdown that comes from, let's say, inherit from the wind farm itself, and that you can always choose whether to you want Youwind to actually model it, or you can insert it as a value because it comes from another source, or that has been that wants to be checked. What is the effect of moving one point, a value of an efficiency? So yes, Youwind offers this open box approach on the full control. Youwind modeled it, or you place it as an input with the full traceability of all these movements.
Okay, last question for Nathianne, because it's already 3:45. Like I said, the other questions, if your name is on it, we will answer them by email, no problem at all. Sorry,
just
Anna?
place them. No, I'm saying like encouraging, right questions.
Okay.
So no stupid questions, only stupid answers.
So last question for you, Nathianne. How can we measure performance of Delfos system?
So we take into consideration the wind speed that is measured by the nacelle anemometers, and with the right corrections on these measurements, just to mention air density correction if it's available, and also nacelle transfer function, which is recommended by the standard IC 61400. We correct these wind speed measurements, and then we calculate how much energy was expected to be the active power, and we compare with the measured active power. So that gap, we attribute that gap to the performance. So if you are near the expected power, your performance is good, but if you are far away from the expected power, you're underperforming, basically.
Perfect. Nathianne, quick question. Still, I see that it's at the beginning, this question. So what's the real difference between using AI predictive tools and just sticking with Scala?
Okay, so very quickly, the SCADA systems in general lack prioritization tool. So if you only use SCADA systems, normally you feel lost among so many alarms and downtimes happening all the time. So using a second layer SCADA like Delfos platform, you can operate better because you have prioritization tools that help you to prioritize what's more important. And also the predictive alarms, they give you more time to be prepared to deal, for example, with replacement of a big component that can take several days, or maybe can take months to get a spare parts, like, for example, replacing a main bearing. So it's all about prioritization tools and having trustful information ahead of time.
Okay, great. And with this, we close the webinar for today. Thank you to everybody who joined. You will get from us afterwards an email with a recording, so you can always look back at it if you need to. In the chat, you will find also a link if you want to know more about Youwind. And anyway, we will give you the contact details afterwards, both from us, from Youwind and Delfos. If you need more information, if you want to speak somebody at the technical team to know more about the platform, if you think it can be useful for you, please don't hesitate to contact us. We will gladly help you. Thank you again for today. It was great. And we hope to see you soon at the next webinar. Thank you.
Thank you.
Thank you.
Bye.
Bye-bye.
Bye-bye.